All right, welcome back. Today, we're diving headfirst into two of the most important ideas in Apache Kafka, partitions and replicas. Seriously, once you get how these two work together, you've pretty much unlocked the secret to Kafka's incredible speed and rock-solid reliability. But first, let's just step back and think about the problem. I mean, how on earth do modern systems handle this constant massive fire hose of data? Every click, every order, every single update from millions of devices. How do they do it without just falling over, or even worse, losing a single message? And that question, that's it, right there. That's the core challenge that Kafka was born to solve. Let's just call it what it is, the streaming data problem. See, the real trick isn't just about handling a ton of data. It's this constant tug of war between two things you absolutely need. You need unbelievable speed to keep up with everything in real time, but you also need total safety to guarantee that no data, not one byte, ever gets lost if something goes wrong. And this is where Kafka's design is just so clever. It doesn't force you to choose one over the other. Nope. Kafka's brilliant solution uses two key concepts that work in perfect harmony to give you both. So, it's time to meet our power duo, partitions and replicas. They are the heroes of this story. And listen, while their names might sound kind of similar, they have totally different jobs to do. And this slide just nails it. Think of it like this. Partitions are all about parallelism. They're the gas pedal, they give you speed. Replicas, on the other hand, are all about redundancy. They're your insurance policy, your seatbelt. They give you safety. One lets you go fast, the other makes sure you get there in one piece. So, what is a partition really? Well, imagine a Kafka topic is like one giant, never-ending logbook. A partition is just a slice of that book. Instead of one huge book that only one person can read at a time, Kafka splits it into smaller, independent chunks. This is what lets a bunch of different consumers read from the topic all at once. That's how you get that massive boost in speed. And a replica? The name pretty much gives it away. It's an exact, perfect copy of a partition. But here's the kicker. These copies are intentionally stored on different machines, or what Kafka calls brokers. Why? So if one machine completely dies, it's no big deal. A replica on another machine is sitting there, ready to take over. Okay, now that we've met them, let's put them side by side. We're really going to hammer home the fundamental difference between the parallelism you get from partitions and the redundancy you get from replicas. This table right here makes it crystal clear. Let's look at purpose. Simple, right? Partitions are for parallelism, replicas are for redundancy. But the data content row, that's the real lightbulb moment. Partitions hold different data. Each one has its own unique piece of the pie. Replicas, though, they hold the exact same data. They are identical twins of a single partition. So if you remember one thing from this whole explainer, let it be this. Any given message lives in exactly one partition. It has one and only one home. But that home, that partition, can have multiple backup copies, those replicas stashed all over the cluster just in case. One message, one partition, but potentially many copies. You know what? Enough with the theory. Let's make this real. Let's actually follow a couple of messages as they take a journey through a Kafka topic. So let's picture it. We've got an orders topic. And to make things fast, we've set it up with 3 partitions. Let's see what happens when a few new orders start pouring in. As those orders come flying in, Kafka is basically playing air traffic control for data. Order A, okay, you go to partition 0. The next one, order B, gets routed to partition 1. And order C, it lands in partition 2. See what's happening? The work is being spread out instantly. Instead of one long single-file line, we've got 3 shorter lines all moving at the same time. That's parallelism in action. Okay, so we're going fast. Awesome. But what about safety? This is where Kafka's safety net comes in. For every single partition, Kafka holds an election and picks one replica to be the leader. All the other copies become followers. Now, only the leader is in charge of handling any new data. And what do the followers do? They have one simple, super important job. Just watch the leader and copy everything it does, instantly. So, for instance, the leader for partition 0 might live on a machine we'll call broker 1. To keep that data safe, there's a follower replica of that same partition humming along on a totally different machine, broker 2. If broker 1 suddenly goes up in smoke, no sweat. The data is safe on broker 2, which can immediately be promoted to become the new leader. 0 data loss, 0 downtime.
Whew, okay, that was a pretty fast tour of Kafka's guts. To make sure all this really sticks, let's just wrap up with a quick, simple cheat sheet.
Let's lock this in. Quick fire round. Do partitions hold the same data? No way. They hold different chunks of data for speed. Okay, but do replicas hold the same data? Yes. They have to be exact copies. That's our safety net. So what gives us that speed, that parallelism? That's the partitions. And what gives us that safety, that peace of mind? That's the job of the replicas. And that's how it all works together. It's this beautiful dance that creates a system that's both ridiculously fast and incredibly tough. But it does leave us with one last, really interesting question. We know a follower takes over when a leader fails. But how? How does that election happen? How does the whole system stay consistent during that switch? Well, that's a story for next time. Thanks for tuning in.